Hi, welcome to the Chico Math Lab differential equation problem solving section. So today, here is the problem we're going to solve. So this is a nonlinear homogeneous differential equations. So what we need to do, so it's x cubed plus xy squared dx plus x squared y plus y cubed dy equal to 0, y1 equal to 1. Okay, so let's take a look. So for this type of the differential equation, and so because this is a homogeneous and the nonlinears, right? So for the homogeneous equations, we have what we call the exact differential equations here. So and let's try to use this methodology. Try to take a look. Like I say, I always like to put the x and the dx dy. All right, so here the dx plus x squared y plus y cube dy dx equal to 0 here. Okay, so for this homogeneous here, right? Okay, so let's see. This term has nothing with dy dx, and then this term here is x squared y cubes here. All right, so now I will assign, so we know, so here is, let me try to kind of do a brief review. So this is for the mxy function plus nxy dy dx equal to 0 if we know the mxy, if you take the, if you take the derivative, partial derivative respect to y, okay, so the f of xy, and then if this one equal to the n, you take the derivative respect to xy. So if they have these properties here, okay, so if they have this property, then if you take the partial derivative, so this is what we call the exact differential equation. Okay, so for the exact differential equation, just like we did for the Bernoulli, we have a certain step. So it's always follow the same steps here. All right, okay, so now let's go ahead and check it here. So like I said, okay, so this is my mxy, and this is my nxy, right? Okay, so now if I want to take the derivative of the y with the variable of the y's here, so x cubed will be 0 because the constants, right? So it's a 2xy. Okay, so then the same thing for the nx of xy. So the nx of xy is x squared plus y cubed. That means I'm taking the derivative for x. So this will be 2xy. Then the y cubed will disappear as a constant. Okay, so let me color it so we can color coding that. So this one is related to that. And this one is related to the, I derive it from the the function nxy. Well, very nice. These two, they are equal. Okay, so if these two, they are equal, then we can use the exact differential equation method to solve it. And I always like to put it into a step-by-steps here. So because we're always going to follow the same step. So the step number 1 is here. After you check, so they are equal. That's good. So we know this is, we call it the exact differential equation. All right. And so then the first step here, we're going to assign some functions here. So I will assign this function 5x, all right, xy. I will assign this one will be my mxy. Okay, so I'm putting mxy. And then I will assign another phi y, xy will be my nxy. Okay, so let's do the same color coordination so we know, what that mean, and so we don't get confused here. I like to put in the color here. Okay, so now after first thing, so I assigned that. Okay, so now my step number 2, like I say, is always the same step, just like when we did the Bernoulli differential equation. It's the same, right? The Bernoulli equations here, step number 2. Okay, so the step number 2, so I'm going to integrate with respect to integrate this yellow function 5xy with respect to what? With respect to x. Okay, so that means my mxy. So here this is x cubed plus xy squared. I only with respect to x, so y is a constant, right? Okay, so now in here I will integrate that. So when I integrate that, so this one's here is like I integrate x dx, right? So I will get what? I will get the 5xy. Okay, so x, so it will be x to the fourth, right? Over 4, then plus x squared over 2 to the y squared. Remember, we have a constant, but in here, since the y is a constant, because I'm in respect to the x. So my constant term really is a function of the y, h of the y. This is very similar like when you are taking the calculus 2 or calculus 3 when we do the partial derivative and then we want to find the function back. So that's how do we do that, right? So this is a 5xy is h of y. Now after you do that, okay, so then the step number 3 is here. Okay, so now I want to take the derivative. So take the derivative of the 5xy and with respect to what? Okay, so with respect to, okay, take the derivative with respect to y. Take the derivative, oh, I'm sorry here. Okay, so I want to take the derivative, okay, so of h phi of xy, okay, so with respect to y here. Okay, so in here, okay, so this is my new, okay, so be careful here, right? So here, this is my 5xy here. So now I want to take a derivative with respect to y. So what I get here, so I will get a phi partial derivative of the y's, right? Now I am taking a derivative for these terms here, right? So with respect to y, because it's respect to y, okay, then the x is a constant here. So then here, x is constant, so x fourth over 4 is disappear. So the first terms will be the y squared, you take the derivative, so it will be x squared y, right? Then h then here will be plus what? H prime y. Okay, and then, okay, so this is my 5. Then step number 4 here. Remember at the beginning, at the step number 1, I assigned the phi, the derivative of y is equal to the nxy here, right? So I will say nxy, so because the 5y xy is equal to the nxy. So what is my nxy here? Nxy is x squared y So it's x squared y plus y cubed. All right. And so this one's here, be very careful. So here, I think this is maybe the most confusing part. This one's here, this function, the 5xy equal to the x squared y cubed. This is from my definition from the step number 1. And also, we just find that the 5y is equal to the x squared y plus h prime y, right? And this terms here, right? So this term is from the one we just derived. Okay, so now that's good, right? Okay, so now the step number 5. Now we can, okay, so the step number 5, because they are equal, so what I can get here, I can get a y cubed is equal to h prime y. That's right, so I can get a y cubed, y cubed h prime y. So now I integrate both sides. What I will have y force over 4 is equal to what? And I can do like this. Okay, so I will say h prime y integrator going to be hy will be 1/4 over 4 plus a constant c here. All right, and now I finally got this one, and finally I got my functions here, right? So my 5xy from the step number 2 is equal to the x force over 4 plus x squared over 2 the y squared plus h prime y, right? I'm sorry, hy. And then from the hy, we just got it. So this is x force over 4 plus 2x squared y squared plus y force to the fourth plus c. Okay, that's it. All right, now the step number 7, what do we do here? We will substitute our initial value. My initial value is y11. All right, so now in here, so the 5x, so I will have the 5x here will be equal. Okay, we can say here the 5x is x equal to square. So here, this will be, we said, equal my constant c here. All right. Okay, so here now I can put in here. So I will set 1. So it's 1/4 plus 1/1. So it's 1/2 plus 1/4 is equal to c here, right? So what is my c here? C is 1, correct? So now my final equations here would just be what? Would just be x force over 4 plus x squared y squared over 2 and the plus y force over 4 equal to 1. That will be my answers here. Okay. So if you see a homogeneous nonlinear differential equation, so the first thing is here, you will check to see they are the exact differential equation or not by taking the partial derivative of the y and the x. If they are equal, then we can use the exact differential equations. So this exact differential equation, those are the steps, right? So first step, you assign mxy to a function 5x, and the nxy is a function 5xy, the partial derivative y. Then we start out the yellow one, so integrate respect to x. So when you integrate, then you will get this is 4y squared plus hy, right? Then the same thing. After you integrate, you take the derivative respect to y. So then this ones here will give you x squared plus h plus y. Then you set these two equal because they are both the partial derivative, right? So they are both you set these two equal because they are both the partial derivative of the 5 5xy to the y's, right? So then you can say hy equal to y cubed. Then you can say hy equal to the y fourth, the plus c's here, all right? And now you can set finally you can set this number is equal to the hy, you put the y over 4, then equal to the constant c's here. All right, so that's it. And so this one is, I like to see when the check the partial derivative they equal to each other. That means you will be able to use the exact differential equation methods here and just follow the step. You will get it. All right, that's it. And I hope this will help you to solve your problems here. And so I will talk to you later for the another problem. Have a good day. Okay, bye bye.